Hi, my name is Selena Noltenius, and this is Lab 23, Kirchhoff's Laws. This is experiment number 1, resistors in series in parallel 1. And this is for Physics 2 Laboratory. So as a little intro to this lab, we used 3 experiments overall that centered centered on Kirchhoff's laws to study the behavior of electrical circuits. In the first experiment, though, the brightness of LEDs placed in parallel and series arrangements was qualitatively examined. So here you see the materials that were used. This is me with all the materials, and then another picture of the circuits kit and the 2 AA battery, the battery holder and the 2 batteries. So for experiment 1, resistors in series in parallel, I have all of my materials right here, as you can see. I have 2 AA batteries placed within the battery holder. I have 4 2-snap conductors. I have one 1K and a 100 resistor. So these 2 resistors. I have a LED light, and then I have a jumper wire right here. And right now we're going to try to see this picture right here and mimic it into my base over here. So that's what I'm going to do right now. Replacing the battery holder here with the 2 batteries, and then replacing the 100 resistor over here. Like this. And we're placing a 2-snap conductor over here. Now we're placing one of the resistors, which is the 1K resistor. We're placing it over here. Like this. Then I'm grabbing another 2-snap conductor to connect my resistors. Like this. And now I'm grabbing my LED light, placing it over here, like this. And then I'm grabbing my other 2-snap conductors in order to connect all of my circuit. And now the red LED light is on, as you can see. Next video. So now I'm connecting the free end of the jumper wire to the point marked A in figure 13, which is this point. And now we're going to see what happens to the LED light as I connect it and disconnect it. So let's see. So the LED light, and then if I disconnect this, it's a little bit dimmer. But once I connect it back again, even if I touch it, but let's connect it. Look what happens. It's brighter. That's very interesting. You see how it's dimmer right here when it's not connected? Next video. Now we are setting up the system in a different way, according to figure 14. So right now I'm putting my resistor, my 100 resistor over here. And then it's going to look a little bit different from the last one. putting this over here, and then placing this over here, placing the 2 snap conductor over here, the 3 snap conductor over here. I'm missing my 1K resistor here, and then this is my last piece with the LED light, like this. Next, now I have turned this from off to on, and now I'm using my let me see my jumper let me see my jumper wire and connecting it from my resistor right here, and then I'm connecting it to point B marked in figure 14, which is right here. So we're gonna observe how this changes. Look at that. So wow, it's a lot brighter. See? And then if we take it away, it gets dimmer again. Now I have turned. So for the results, one of the questions for the post lab was, how does the brightness of the LED change when the second jumper is connected in step 3? What kind of change in the net resistance does this indicate? When the second jumper is connected, the LED's brightness increases even more, showing still another decrease in the net resistance. This demonstrates how adding more parallel pathways is lowering the total resistance and increasing the amount of current that can pass through the LED. So as seen, the net resistance of the circuit before the jumper is connected is higher because there is only one path for current flow. After the jumper is connected, the net resistance decreases because the jumper creates a parallel path, allowing more current to flow through the circuit, thereby decreasing the total resistance. Thank you.